right, so for this week, our focus will shift from rational expressions to rational equations. Okay, so we're still going to be doing what we did last week, but the key difference over here is that now you're going to have a rational expression equal to, in this, it could be another rational expression, it could be a constant, whatever, but you will have an equation. Okay, so the key difference this week is that you're going to have an equation, and when you have an equation, then you can actually solve for x. Okay, so that's the only difference. Now, this question, right? For the starter question, I think you can all solve this question. So again, you can pause the video, I guess, try solving this question. The best approach would be to cross multiply, okay, because this is what you were told. But again, I'm giving you a simple question, and I'm kind of gonna highlight why is it that you cross multiply? Where does cross multiplication actually come from? And why does it work? Okay, so solving this question is not too difficult. Okay, so as long as you cross multiply. Um, but I'm going to go a little further in detail and tell you why we have to cross multiply, or why does it work. Okay, so whenever you get a question like this, the first thing that you should do is try to get rid of your denominator. Okay, why? Because it's difficult to work with fractions. Um, but if you can get rid of your denominator, then it makes the algebra very easy. Okay, so before we get rid of the denominator, I think one thing that you should do is always start off with the non-permissible value. Okay, so just mention that x cannot equals to 1. Okay, so we're assuming that x is not equals to 1, and then we're gonna um, um, do algebra and solve for x. Now, if we do algebra and let's say our answer happens to be x is equals to 1, okay, which I don't think it is in this case, but if this is what we get, then we're going to have to reject this value because remember, x cannot equals to 1. Okay, so sometimes that might happen, especially when you have a quadratic function. But anyway, let's not make this too complicated just yet. So the goal is to get rid of the denominator, right? That's what I said. So how do you get rid of the denominator? Well, what you have to do is maybe let me just rewrite this equation again down here. So you have 10 over x minus 1 is equals to 5 over 2. Now, see, the thing is, if I multiply my left-hand side by x minus 1, okay, then whatever you do on one side, you have to do the same thing on the other side, right? So that's good enough for me. I was able to get rid of one of my denominators, but there's actually another one, right? So your goal is to get rid of all your denominators. Okay, so in that case, what you should do is you should not only multiply by x minus 1, but you should also multiply by 2. Okay, and the way I like to do it is, I mean, you could do this on both sides, but my way of doing it, just to save some space and time, I just multiply. I just put this in brackets to indicate that I'm multiplying the whole thing by 2x minus 1. Okay, so when you do that, again, if you want to do it on the left side and right side separately, you're more than welcome to do so. But I think this way it just you kind of like do both things at once. And I think, in my opinion, this is a better way of doing it. So when you multiply by 2x minus 1, the x minus 1 and x minus 1 will cancel over here, right? So you're going to be left with only just this 2 will survive. So 2 times 10, so that gives you 20. Okay. And this is equals to, now you're going to have to multiply this guy by the 5 over 2 term. So the 2's and the 2's will cancel, right? And the only thing that survives is this x minus 1. So this will just become, and the 5 over here, right? So this will just become 5 times x minus 1. So 5 times x minus 1. Okay, so again, the reason is because your denominators will cancel out. Okay, so in the first one, right, maybe let me use a different color. So in the first one, the x minus 1 will cancel with the x minus 1, which leaves you with just 2 times 10. That's where you get the 20 from. And the second one, um, you will have to cancel. So let me use green, right? You're going to have to cancel the 2 and the 2. But remember, this x minus 1 term is still here, okay? It's still here. And then that multiplies with the 5x minus 1, okay? So um, I hope this is kind of making sense. If not, then what you could do is maybe multiply separately on both sides, okay? So um, yeah, so just be careful when I'm crossing out the x minus 1 with the x minus 1 over here. That's only when I'm multiplying these two terms together. Okay, now when I have to multiply the next one, then this x minus 1 will reappear. Okay, so yeah, so just be careful with that, or multiply on the left and right hand or left and right hand side separately to avoid that confusion. Okay, altogether. So anyway, I'm gonna proceed. So this just becomes 20 is equals to 5x minus 5. And then all you have to do is just solve for x, right? So let's just get rid of again, you have two obstacles, right? Which one should you get rid of first? In algebra, remember when you have to solve for something, you always have to follow BEDMAS in reverse direction, okay? So this will tell you that you need to get rid of addition and subtraction before multiplication, okay? So let's get rid of the subtraction by doing the opposite, plus 5 plus 5. This disappears, and then you have 25 is equals to 5x. And then you have to divide by 5, divide by 5, and then x is equals to 5. And then you can check, okay, x is equals to 5. Go back into the equation, right? So 5 minus 1 gives me 4, right? So this becomes 10 over 4, and if I simplify that, I'm going to get 5 over 2. Okay, so it does work. And again, I'm not going to reject this value because my restriction was that x cannot equals to 1, and this is 5, so I don't really have an issue over here. Okay, so this is your solution, okay? And it's a unique solution. There's only one. But sometimes you might see quadratics appearing, in which case you might have two. And in some cases you might have to reject one of them, okay? So now let's see this question, okay? So I have to solve for x here. So I have x over 4, 7 over x is equals to 3. Okay, again, the first step is to make sure you figure out what the non-permissible value is. And in this case, I have two denominators. Only one of them can become 0. So my only restriction is that x, or the non-permissible value in this case, is that x cannot equal to 0, okay? So that's important. That's the first step. And now, again, like I said, whenever you get a question like this, right, your goal is to get rid of your denominator. So I have two of them. So in this case, I'm going to do this question a little differently, okay? Because you guys might get confused. So I have two denominators, so I'm going to multiply by 4x, okay? Because I need to get rid of both of them. Now I'm going to do the same thing on the on this side, but we're going to run into the same problem. Or you could multiply the whole thing by 4x, okay? However you want to do it. I like to multiply the entire equation. So something like this. I'm just going to put my brackets over here to indicate that I'm going to multiply the whole thing by 4 minus x, okay? So when you multiply these two together, right, the 4's will cancel, but the x survives, right? So this will just become x squared, okay? Now if I multiply these two, then the x will cancel, and the term that survives is 4. So I'm going to multiply 4 by negative 7, which gives me negative 28. Okay, so this will become negative 28. Oops. And then I have, now don't forget about this guy, okay? Don't forget about this guy. Again, if you would like to multiply your left-hand side and right-hand side separately, you could do so. But this is how I like to do it, multiply the whole thing together, okay? At the end, it's going to work out to be the same thing. So 4 times 3 gives me 12, and then this is x, okay? Now, how do you solve a quadratic, right? The best way to solve a quadratic is to make it equals to 0. So this just becomes x squared minus 12x minus 28 is equals to 0. And then just try product sum, right? Because you have three terms. Product sum would be your, I guess, a faster way of doing this. But if you would like to go with the quadratic formula over here, you can do so as well. Okay, so I'm going to try product sum. So I'm looking for two numbers. Let me just do this over here. That multiply to negative 28, and they add up to what is it? They add up to minus 12. Okay, so start again. Start with 1 and 28. That's not going to work. 2 and 14, I think will. Okay, so 2 and 14, I get, so one of them has to be negative. Now, because this is negative, the bigger number has to be negative, right? So 2, 2 positive 2, right? It has to be the same two numbers. And then this one is minus 14. Okay, so because my coefficient is 1, right? The coefficient is 1 over here. I can just use my shortcut. So this just means that x plus 2, x minus 14 is equals to 0. So if I solve for x, right, either x will equal to, again, I guess I'm going to show all my work, but it's very easy to figure out what the x's have to be, right? So either x plus 2 is equals to 0, right? Or x minus 14 is equals to 0, and then you can just solve for x. So x is equals to minus 2, or x is equals to 14. Okay, and then you can check, right? You can check, you can plug in those values and see if that actually gives you the right answer. So because I don't have much time, I'm not gonna do that. But I will just tell you what needs to be done. Okay, so just plug in the x value over here. So plug in x is equals to negative 2, x is equals to negative 2, and see if it actually works. Okay, I'm just gonna do negative 2. So negative 2 over 4, oops, over 4 minus 7 over negative 2. Okay, so this just becomes minus a half, and then you have a minus and a minus, so this will become plus. Okay, and you can do this in your calculator if this is kind of bothering you. And then, okay, so this becomes plus 7 over 2. So because now I have the same denominator, right, I can just add my numerator. So minus 1 plus 7 is 6 divided by 2, which is equals to 3, which is what I have up here. Okay, so this one does work, and that one will also work. Okay. The only time you're going to be rejecting your value is when your value happens to be the non-permissible value. Okay, in this case, none of my solutions are the non-permissible value, so both of them will work. Okay, so just be very careful with the non-permissible values because you always have to verify this whether these solutions are the same as the non-permissible value or not, okay? Because if they are, then you're gonna have to reject them, okay? Um, Otherwise, yeah, obviously, like it's not gonna work, right? Because you can't divide by 0, okay? So now let's do something more complicated. So again, this question looks very complicated, right? So first thing that you need to do is identify the non-permissible values. So this guy needs to get factored. Okay, so let me rewrite the question then. So 9, so you know what, let me just factor this first. So I'm looking for two numbers that multiply to 18, and they have to add up to minus 9. So 6 times 3, right? Again, if you're not very good with this, try 1, 2, 3, and then you'll see that 3 times 6 will actually work, but then both of them have to be negative, okay? To make this positive, and then, so this is minus 3. This is minus 6. So because the coefficient is 1, it's really easy to factor that. So let me just rewrite this over here. Y minus 3 minus 4 over y minus 6 is equals to 18. So it's just y minus 3 and then y minus 6. Okay. So this is actually very nice because I only have to multiply this by y minus 3 and y minus 6, and the same terms are repeating over here, right? So my algebra is not going to be that messy. So to get rid of all of my denominators, I need to multiply this by y minus, so I'm just going to write this over here, y minus 3, and then y minus 6, okay? So when I multiply the first term, right, the y minus 3, y minus 3 will cancel out, right? So that will leave me with 9 times y minus 6, okay? Now when I multiply my second term, the y minus 6 and y minus 6 will cancel out, which will leave me with minus 4 times y minus 3, right? Y minus 3 will survive. And in the last term, both of them will cancel out, okay? And the only surviving term will be 18, okay? So 18. And then, right, now you have to kind of like clean this up, which means that you need to get rid of your brackets so that you can combine the like terms together. Okay, so just distribute, get rid of your brackets. So this is just 9y. 9, 6 is 54, I think. Yeah. And then minus 4y plus 12. Just be careful with your signs, right? When you multiply two negatives, you're going to get a positive. So if you're not very good at this, again, double check with your calculator, okay? So 9 minus 4 will give me 5y, right? So if you want, combine the like terms, or, like, let me just do this. So you can combine them together, and then you combine your constant terms together. So the negative 54 with plus 12. Um, so let's clean this up a little bit. So if I combine that, I'm going to get 5y is equals to, oh, sorry, not equals to, 5y, and then the negative 54 plus 12. So negative 44, negative 42 is equals to 18. And then you're going to, just do plus 42, right? Plus 42. So that's 50, that's 60. So 5y is equals to 60, and then you divide this by 5, divide this by 5. So y will just equals to 12. And then obviously just check if this is the right answer. And also check if, oh, I didn't list my non-permissible values, right? So list your non-permissible values, right, by looking at this factored um, equation, right? Everything is factored over here, including this. I know that y cannot equals to 3, and it cannot equals to 6, okay? Because 3 and 6 will make my denominator 0. So the solution that I have is 12. And if you check your work, right, if you compare the 12 to the non-permissible value, they're different, right? So that means this is your solution. And just to be on the safer side, please check your work, okay? So I'm not going to do that in the interest of time, but I think this is your solution, okay? So please check this for yourself. But because I'm getting a nice whole number, I think, you know, I think I'm on the right track. Okay, but sometimes you might get decimals, right? And if you do, don't think that you got the wrong answer. Just check. Okay, so plug y is equals to 12 in here and in here. Find the value of this using your calculator, and then plug y is equals to 12 in here. Find the value of this using your calculator and compare the two. They should be the same. If they're not the same, then either you're checking incorrectly or you did your work wrongly. Okay, so yeah. So this question is done in your textbook on page 343. Okay, the question is given to you in 342, but the solution is given to you on page 343. I'm not going to work this out in the interest of time. Okay, but what I will point out is remember, your goal is to get rid of your denominators, right? So this screams to me that this is a difference of squares. So you're going to have this, so z plus 2, right? And then z minus 2. Now you have to factor because obviously you need to know what denominator you need to get rid of. And also it will tell you what the non-permissible value is, okay? And this I'm probably going to have to factor. So I'm just going to factor the 6 to get z plus 2, okay? And then finally I have 1 over z minus 2. So the things that I need to get rid of are z let me just put this in bracket just for you. So the stuff that I need to get rid of is z minus 2, z plus 2. So that means these guys will be taken care of, but don't forget about the 6, okay? So, and I think that's what they're going to do in the textbook. They're going to multiply the whole thing by 6, z plus 2, z minus 2, okay? And once you do that, you're going to get rid of all your denominators, and also make sure you list your non-permissible value at the very beginning, okay? So work this out. I've kind of given you, you know, a strategy that would work, and just try this out and compare your solutions in the textbook, okay? And obviously check your answer. And I think there's one solution to this. Yeah. So check your answer. And I think in the textbook, they're doing that for you as well. Okay. So um, page 343. Okay. So page 343, just look that up. I'm going to continue because I don't want to make my videos too long. And I think this is the only question that I'm going to do like one more. So again, I'm doing the your turn questions now because the solutions to this is not given in your textbook, okay? But before the your turn question, there's another question that comes. But this solution to this is given in the textbook. So I'm just gonna, give you a hint and then you can kind of like finish this off and compare your answers, okay? So um, anyway, so let's do this one. So again, this one is not factored, so I'm gonna factor this. Two numbers that multiply to -6 and they have to add up to -1. So try 1 and 6, that's not going to work. 2 and 3 will work. One of them has to be negative because this is negative, the bigger one has to be negative. Okay, so -3, 2 minus 3 is -1. Okay, and because my coefficient again is 1, it makes my life really easy. Okay, so I'm going to write this this way so that I have enough space on the left to multiply. So -5x minus 3 is equals to -25 over x plus 2 x minus 3. Okay, so same thing as before, right? Multiply the whole thing. You need to get rid of your denominators. Also, maybe let me just erase this, okay, so that I can point out what the non-permissible values are here. So your non-permissible values are x, well, after factoring, right? I know that x cannot equals to -2 and it cannot equals to 3. And those are the only ones, okay? So now you will have to multiply this by x plus 2, x minus 3. And then once you multiply that by this, these guys will automatically disappear, okay? So there's no third term. So this one's actually a little easier than I think what you guys will get. So just multiply this, right? So now I'm multiplying the whole thing, right? That's why I've put my brackets over here. So when I multiply the first term, then the x plus 2 and x plus 2 will cancel, right? Which will leave me with 3x times the surviving term, which is x minus 3, okay? Now, in the second term, the x minus 3 and x minus 3 will cancel. So this -5 will have to multiply by the x plus 2 term that survives, right? So I'm going to multiply -5 by x plus 2. And then finally, in the last term, everything will cancel out. So it's just the -25 that survives, okay? So this is just equals to -25. And again, right, you'll have to clean this up a little bit to combine like terms. So let's do that. So when I do that, I will get, let me just stick with the red color. So 3x squared minus 9, right, minus 5x, and then minus 10 is equals to -25.